Hello, everyone. Welcome to Memgraph Community Call. Um, Michael is today here with me, but he doesn't have his camera today. There's a bit of technical difficulties, but no worries, he is still here and you will hear his voice and him presenting. So, hi everyone, and welcome to another Memgraph Community Call. Today, it is my pleasure to introduce Michael Marganelli, the CTO and co-founder of Smart Buildings. I first met Michael in Memgraph community, where his enthusiasm for graph technology immediately stood out for me. His passion for this field is really nice, and I knew that he would be an excellent addition to our community call to share his insights and research. And as you know, in the world of graph databases, we tend to see everything in terms of connections, and essentially, we see a graph data model everywhere. So for those who are deeply familiar with graph data model, this concept of digital twin for smart buildings that Michael will talk about, that is stored in Memgraph, might not come as a surprise. However, for those who are maybe not familiar with graph data model, less acquainted with the domain, as I once was, this talk should provide valuable insights into what can be achieved with graph technology. But I will let Michael share more about this and himself during the presentation, and I encourage you all to engage actively. So feel free to have a chat in the chat tab on Livestorm. If you have a question, ask in the questions tab. This will make it easier for me to manage it later when we will have a short Q&A session. Also, my colleague Mata will be posting a few polls, so please answer to them. I will remind you that she posted them. And I think that's it, that I shared everything with you that I needed. And without further ado, I will hand over the stage to Michael. I think we are all eagerly looking forward to his presentation. So Michael, the stage is yours.
Well, thank you very much for that warm introduction. I'll just get my screen going here. Thank you, everybody, for coming to my quick discussion on constructing a digital twin using Memgraph. My name is Michael Marganelli, and I'll provide a brief introduction to myself and Smart Buildings. This is the agenda that I'm hoping to follow today. So, like I said, we'll provide a brief introduction to Smart Buildings and myself. Then we'll introduce what a digital twin is for those who may not be familiar with the term. And then I want to take you on a bit of a story. We're going to start with the problem that Smart Building and our client faced. And then we're going to walk through these 3 steps that we followed to solve this problem, which was the beginning of this was using Memgraph as a facility index. We'll explain sort of how we did that, how that laid the groundwork for what would become a digital twin. And then the next step, which was enriching that digital twin with sensor information. We'll explain why that is important for us, how that fills in. And then we're going to describe the 3rd step that we took towards our digital twin, which was enriching that graph database using telemetry data and why that was so critical. And then some future steps that we hope to follow, as well as our conclusions. And then if we have time, a Q&A, which I'm looking forward to. So first, a brief introduction to Smart Buildings. Smart Buildings was founded in 2021 by partners myself, Michael Marganelli. I serve as the Chief Technology Officer. I have about a 20-year history in building automation systems and technology. I've developed lots of different software. I've managed different technology stacks, and I conduct independent security research on commercial automation technology. I am based out here in the Okanagan in British Columbia in a small town called Kelowna, for those who may be familiar with it. And then my business partner, Gord Erickson, serves as the Chief Strategic Officer. Gord he's a seasoned executive with over 20 years of experience in technology, construction, and industrial control systems. Also, Gord is an expert in electrical metering systems, and he is based in Ontario. Smart Buildings, or SBIO, as it's going to be referred to later on in this presentation, we were founded as a building automation system, or BAS, security provider, focusing on auditing and providing mitigation strategies for small to medium BAS systems. A BAS system, for those who may not know is a control system inside a building that manages things like your boilers, your chillers, your air handlers, your crack units and rooftop units. So they're responsible for the internal HVAC, but it could also be connected to your, HVAC, heating, ventilation, and air conditioning. But it could also be connected to your lighting control system. There could be tie-ins to a security system as well. So the umbrella term for all of that is known as the building automation system or building control system. We also provide other services, and we specialize in integration of alarm management for enterprise level BAS and industrial control systems, or ICS. And an ICS is very similar to a BAS. It's just more geared towards the industrial side of things, hence the term industrial control system. So what is that? Whoa, my apologies. Let me just jump back to where we were. So what does that mean for SBIO? Well, it means that we focus on three major tranches. The first major line of business is an ICS security management. So we provide auditing services as well as solutions for remote access and VPN networking. What this means is that if you have a building automation system that you need remote access to, and you want to do it in a safe and secure way, those are services that we can provide. Or if you have a vendor, you know, a Johnson Controls or a Allerton or something like that, who needs access to your system, we can provide that in a safe and secure way. The second major line of business is around integration and software development. So we are a software development house. We develop custom software for integration between systems that may not speak, that may speak different languages. So if you have a BAS system and you want to integrate your electrical metering system, and one may speak one language, the other may speak another language, we can provide the middleware to allow those two systems to talk. Or if you have a robust building automation system and you want it to tie into some some business automation program that you have around fault detection or analytics, we can provide help there as well. And the final major line of business that we operate in is around air and water intelligence. This is more towards the IoT scheme of things, or the Internet of Things side of the world. We deploy and monitor air and water sensors to detect environmental risks, such as flood or poor indoor air quality. There's a number of other sensor packages that are available around air and water. So air pressure, temperature, humidity, particulate count, things like that. And around the water side, we do water flow, water flooding, things like that. So those are the major tranches that we operate in. Pardon me. Our current clients include real estate management companies, network and technology providers, as well as heavy industry. What's missing in that list is also federal governments. We work for the government of Canada as well. So that's a brief introduction into smart buildings, who we are, what we do, and sort of the areas that we operate in. Now I want to give a brief introduction into what a digital twin is, for those who may not be familiar with the term. Now this is a lot of text on a slide. I'm just going to read it very briefly, and then I want to talk about the picture on the left-hand side. So a digital twin is a virtual representation of a physical asset, such as a building, a system, or a piece of equipment. A digital twin is designed to mirror the real-world counterpart in real time, giving up-to-date status and telemetry. Utilizing a digital twin for complex systems allows for more streamlined operation, maintenance planning, and alarm management. Now that's a lot of text, but what it means essentially is, if you can imagine that you have, looking at this picture on the left-hand side, we have this airplane that's a physical asset, and we want to manage that physical asset in virtual space. There's a lot of parameters about that physical asset that are important to us, such as its engine speed, its altitude, its airspeed, its fuel level, its internal temperature, internal pressure, position of the ailerons, things like that. Those are all physical characteristics of the physical object that we can mirror digitally, which then provides us a virtual representation of what that physical asset is doing right now. And it's the data that connects the two models. So we have the real world model, which is the physical asset. And then we have the digital model, which is the representation of that physical asset. And it's the data that glues the two together. I think that explains sort of what we're getting at towards a digital twin, a virtual representation of some physical asset. And that physical asset could be a single object, in this case, an airplane, which is by no means a simple example. Obviously, there's quite a few complex systems. Or it could be an entire building. You could build a digital twin of an entire building, as we're going to see in a few minutes. So now I want to explain what the problem was that we faced with one of our clients. So this particular client is an enterprise level property management firm in Canada. They manage thousands of properties across North America, both in the United States and in Canada. In each one of these buildings, they have a building automation system in one form or another. That could be a very complex system with servers and workstations and, big chiller plants, or it could be a very small system with just a few smart thermostats. The problem that they were facing was that each one of these buildings was generating alarms. Building automation systems generate alarms when conditions are not optimal. And so each one of these buildings was generating alarms. And they have different vendors with different systems, which and desperate alarm notification methods. In some cases, they would email out to a distribution list. In some cases, it would go to a central dispatcher. Some cases, it would go to a BAS vendor. In some cases, it would page the guy who's on call. And it just led to a lot of confusion. And so SBIO partnered with this client to develop an alarm management system. And so now SBIO receives hundreds of events per day through multiple different signal pathways. And all of these events are collated and consolidated under one single platform. So regardless of whose system is in the building and what type of alarm they're sending, it could be a temperature alarm saying that a room is too hot or too cold, or it could be an equipment alarm saying that a chiller has failed or an air handler has failed. They could even be security alarms saying a door has been left open. All of these alarms are fed under one single dashboard for operators to view. So now we come to the present day. SBIO is now collecting sensor information from and alerts from all of these facilities. Alerts are being generated internally. So we would generate alerts when we measure a temperature and that temperature is outside of a predefined threshold. Or third-party vendors were generating alerts and sending those alerts to us. But really, we had no real picture of what was going on in these facilities. We just had a stream of alerts coming to us without any real picture of what was going on. And we realized that we had an opportunity here to build a digital twin of the facility. Since we had all of this digital information coming to us, we could model what was happening inside the facility if we had more information on the equipment and more information on what points, what parameters that equipment could send us. If we go back to our example of the airplane has engines, and one of the parameters that engine will send back is its speed. So in this case, we can do the same thing with our facilities. And we saw this as an opportunity to build a digital twin for these facilities. So how did we go about doing that? It's not just as simple as saying, oh, well, I want a digital twin. Let's go and do it. There are definitely some steps to follow. So for us, this was sort of the story of our journey. First, we had to lay the groundwork of a digital twin. And for us, that was building up a facility index for all of these facilities. And just looking at this slide here, we can install an edge device on our customer facilities or have alarms sent to us over an API. And if we look at our picture on the lower left-hand side, we have our edge client, which is just a small computer sitting in the client's facility that goes out and measures temperature sensors or the status of a boiler, or the status of a chiller, things like that. And it will read this information back to our infrastructure. The other example is a vendor will send us an alert over to an API. And for those who don't know, an API is essentially an open channel on the internet that you can send. Think of it like a mailbox that you can send letters to. And in this example that we're going to look at, a vendor is sending us alarm information to our API. These alarms contain information including an ID number and a building, an ID number for the device, for the facility in alarm, and the device that's actually in alarm. And if we look at the red square here, which is an example of an alarm, now this is obviously a simplified example. There would be a lot more information contained here, but we see there's an ID number for a facility. It's 43651 and device 12356. So we need to build, now those numbers, they mean something to the computers, they mean something to the system, but for a human reading the alarm notification message, it doesn't really mean much to them. So SBIO needed to build up a database of ID numbers and human readable names. Or we had to go back to the vendor and ask them for the name of this facility. So when an alarm comes in, we would then have to go back to the vendor through another API and say, well, can you tell me the name of facility 43651? And can you tell me the name of device 12356? So that was one solution. The other solution was to build up a facility index where we would call on a database to say, well, can you tell me the name of 43651 and its facility A in this example? Now, historically, this is done with a traditional database or a traditional relational database where you have a series of linked tables. So example, this table, the facility table here would say, well, I have facility A, facility B, facility C. And facility A belongs to this client, facility B belongs to this client, etc. These databases can get very complex when you're dealing with thousands of facilities, each one that has their own devices. They could have up to 1,000 devices in a facility. So you can imagine that these linked tables in a database would get very complex. So SBIO took the opportunity to start a digital twin by leveraging Memgraph. So rather than a traditional relational database, we built up a graph database containing all the facilities that we were able to scan, with the plan to extend this into a digital twin by adding further relationships. So at the moment, it's not a true digital twin. All we have really is a graph database of facilities, but it's the start, it's the foundation of what would become that digital twin. Using Memgraph as the facility index significantly reduced our message processing time and resources by reducing the number of API calls to our vendor. So if we go back to this example, every time an alarm comes in, we would either have to make another API call back to the vendor asking for the facility and another API call asking for the device. So every alarm would equal 2 additional API calls. And you can imagine we get hundreds of these alarms per day. That's a lot of API calls, a lot of processing time, a lot of network traffic that's not required. The other option, going the database route, reduces the amount of processing time, but Memgraph being a memory resident graph database, its processing time was significantly faster than using an SQL database. So that was the beginning of our digital twin. That was the foundation of our digital twin, was this facility index. Now we want to create a true digital twin by modeling what's going on in the actual building by enriching this digital twin with asset information. So in our case, the asset, in our previous example, the asset was the airplane. If we go back to that example that we showed earlier, in our case, the asset is the building automation system. That's what we're trying to monitor. And this is a very simple example of a building automation system. We have a server and a workstation. We have a chiller, a couple of thermostats on the wall, and a boiler. Now, each one of these pieces of equipment will have parameters inside that we can monitor. Just like the airplane had engine speed, altitude, position of the ailerons, etc. These pieces of equipment will also have parameters that we want to monitor. Those are called, in building automation systems parlance, those are called points. So what SBIO did was build software that would scan this building automation system network for all of its equipment and then get back all of the points, all of the parameters that we could modify or that we could reach, for that piece of equipment. So if you look here, the chiller, as an example, has 3 parameters that are accessible to us: a chilled water temperature, a chiller status, and a chiller command. The zone temperatures each have 1 parameter that's available to us, zone temperature. And the boiler has 3 parameters: its boiler temperature, its boiler pressure, and its boiler status. Again, this is a very simplified example. In a normal example, a chiller could have hundreds of points that are available, a boiler could have hundreds of points, and thermostats on the wall could have tens of points each. So SPIO built software that would go out and scan these pieces of equipment for their points and develop an internal graph database of what this building looked like. And so these BAS points and devices were attached to a facility nodes in Memgraph, creating a more enriched digital twin. And we end up with something that looks like this. We have our customer in the center, and we could have multiple customers. This is one simple example. So we have our customer with 4 facilities, and in this particular facility, we have these 5 pieces of equipment. We have our chiller, we have our thermostats on the wall, and we have our boiler. Now that we've gone into these pieces of equipment to see what types of parameters they have, we also can see that we have 3 points in the chiller: our chilled water supply temperature, our chiller status, and our chiller command. Our zone temperatures each have their parameters, and the boiler has its parameters. So now we have a much more enriched, we have an actual digital twin now where we can see and model what's going on in the buildings. Now, we can't see in real time what's happening in the building yet, but we now know when we get an alarm for a boiler from facility 4, we know what that boiler is, and we know what parameters to that boiler that we have access to. So this gave us sort of the first real step towards our digital twin. So step 3 is kind of where the fun begins. This is enriching that digital twin with live telemetry data and creating a true digital twin of what's going on in the facility. So as a matter of course, as a matter of our day-to-day operations, we monitor BAS points for their current values, or BAS parameters for their current values. So we have our edge client here in the customer's facility that sends out a message over some protocol that is compatible with the system. In this case, I'm using BACnet as the example. BACnet is probably the most, if not one of the most common building automation system languages. So we would send a message out saying, please give me your points. The boiler would respond with, well, my boiler temperature is such and such, and my boiler pressure is 50 kPa. And I'm pulling these numbers out of the air. This is not an actual operating pressure for a boiler. And my boiler status is I'm on. So we pull this live information from all of the equipment inside the facility. This is what we refer to as telemetry data. So this live telemetry data is then fed up into a system called InfluxDB, which is a time series database. It's very similar to a traditional relational database, or the difference is that it's optimized for time series data. And time series data is sampled interval data. So typically it's data that comes with a value and a timestamp. So at 12:15, the pressure was 50 kPa. At 12:20, it was 20 kPa. That's time series data. And we use InfluxDB to store that information. This data is also fed into our infrastructure where we have alarm parameters set. So in this case, is that 50 kPa less than 100 kPa? And 100 kPa would be the threshold for an alarm. And so yes, it is. We would generate an alarm that would go to our client. Now, we can also use this data for enriching our digital twin. So by storing this telemetry data, which you see in green, storing this telemetry data in the corresponding nodes in Memgraph can create our to further enrich our digital twin. So now we have this live stream of data going from the boiler through our edge client device, through our infrastructure, and landing in Memgraph, landing in our digital twin. So now our digital twin looks something like this. We still have our customer with its facilities in the center. We have our equipment in red and our parameters in blue, just as we had before. Only now we've enriched that a step further with the green telemetry data. So we can now get a more fulsome picture of what's going on inside the facility. We can say that inside facility 4, we have a boiler called boiler 1, and that boiler's operating temperature is 78 degrees Celsius. And we can see all of that from our Memgraph digital twin, which is kind of exciting. So where do we go from here? What future steps do we have planned for this digital twin for this project? Well, there's a few steps that we want to take. We are looking at enriching the digital twin with maintenance and safety plans, extending the coverage of the digital twin to all facilities and all equipment, which, as you can imagine, is a tall order, but it's something that we're actively engaged in. And we want to connect service representatives to the digital twin model for ease of maintenance. So now if we look at sort of a future plan of what our digital twin would look like, we can see that we have our lockout tagout procedures, we have our maintenance records and safety plans that can all be linked to the equipment within your digital twin. Going back to our example of the airplane, you can imagine not only do you have the live telemetry of what the engines are doing, but you also have access to, well, what's the maintenance records on those engines? What's the safety plan for when maintenance is required? And in a building automation system, in a building BAS system, having these readily accessible is really important. So what conclusions do we have? Well, for us in this journey, Memgraph was the perfect solution for building up our digital twin. It had extremely low barrier to entry. Memgraph is very easy to get off the ground and running, whether you're using Memgraph Cloud or whether you're using your own on-prem deployment. Very fast response time. Being an in-memory resident graph database, our response times are very, very fast. Unfortunately, I don't have any metrics to show you, but colloquially, we know that they were performing much faster than SQL calls. It eliminated the need for complex lookup tables. Going back to our original example where we made the decision to go with Memgraph, having complex lookup tables that have to be maintained would have been a bit of a maintenance headache. We can store asset information as well as relationships to points and buildings. So within the one graph database, you can see relationships to pieces of equipment. You can see relationships to other pieces of equipment. You can add the alarm information, so you know when an alarm comes in, you know what equipment that affects. You can also add relationships such as when I take a boiler offline, is it going to affect my thermostats on the wall? Things like that. Our results, our graph database that we're working with right now resulted in about 2,800 facilities, 3,700 pieces of equipment, and about 4,000 BACnet objects. So 4,000 parameters that are loaded in our digital twin at the moment. And we're continuing to build this up. It's a work in progress right now, which is a lot of fun to work on. So that's it. Thank you very much for your time today. As I said before, my name is Michael Marginelli, and this is my contact information if you'd like to reach out, michael@smartbuildings.io. You can reach us at smartbuildings.io for more information, or if you have further questions, or if you'd like to discuss digital twins or any other topics further. But that's all I have for you today, and thank you very much for listening.
Oh, thank you, Michael. Yeah, I guess that all the others are also clapping. You see the reactions here, but sadly you cannot hear them. It was a really nice presentation. Thank you so much for presenting it. I love how you showed us the whole topic of digital twins to get us familiar with that, but as well showed us the importance of graph technology within that. So we have 2 questions, I think. Let me just see. Okay, we have a question. So how are you ingesting the data into Memgraph?
Good question. So Our Memgraph deployment is centralized, but our edge clients are obviously out on the edge. What we've done is we wrote some custom software that would essentially scan the building automation systems for their points, for their equipment and their points, and it would output this into JSON format. And then we would take that JSON format and have basically an ingester on the other side, which would read that JSON file or that JSON output from the edge device and create the required nodes and relationships in Memgraph. So it was at the moment, it's still a two-step operation. We're hoping to streamline that if, as this project gets legs and continues to grow. But at the moment, that's how we're doing it.
Mm-hmm. Okay, thank you. So another question is the asset information enriched with semantic capabilities and knowledge?
Sorry, can you repeat that?
Is the asset information enriched with semantic capabilities and knowledge?
Not at the moment. This is still a work in progress, and this is still a bit of a it's still a bit of a POC for us. So at the moment, it's just limited to the asset information as we have it. We're looking to get a feed in from our client's asset database where they have all of their asset tagging and asset information. We're hoping to continue to grow the digital twin so that we have a feed into their asset database so that we can bring that information across or live link it from one to the other.
Mm-hmm, thank you. I think that answers this well. And we have another question from Max. So Max firstly apologizes if this was covered at the start of the call, but I think it doesn't, it's okay to repeat it as well. So what gave you the idea to look at graph databases in the first instance? Like, what was your motivation?
Question.
Yeah,
good question. So for us, when you look at a digital twin, if you're trying to visualize what a digital twin sort of looks like in digital space, it really is a series of nodes and relationships between those nodes. If we go back to our example of the airplane is related to the the airspeed the airspeed of the airplane is related to the engines. So the parameter is related to the physical, that piece of equipment. And then the engine performance is related to several other different current parameters in the control system, right? Its altitude is dependent on the position of the ailerons and the airspeed and things like that. So by its nature, a digital twin is already dependent on relationships from one entity to another, from one piece of equipment to another. And so when we looked at how we were going to build this, a graph database was a natural choice for us because of its inherent linking of nodes based on relationships, if that makes sense. Basically, when we envisioned what a digital twin should look like, it's really you're connecting disparate pieces of equipment or parameters in such a way that they make sense in how the whole is functioning. And that kind of made a lot of sense in a graph database, because a graph database, very visually, you can see how the whole is functioning based on its parameters. If that makes sense. I hope that made sense.
I think yes, maybe. I don't know if Max would agree. I think yes. And I would also like to add that not having a strict schema in Memgraph, in graph databases, is really something that makes this easier.
Yeah, that's very true. A schemaless, being schemaless also makes it a lot easier. You're exactly right, because you can mix a lot of different pieces of equipment that may on their surface not have a lot in common. So you don't have to worry too much about schema and things like that.
Yeah, that's a really nice feature. And I love how you presented the part of having the less API calls. Can you give us like some sort of a number of how that changed from before?
For sure. So in that particular example, it's kind of an interesting story, but basically in that particular example, the vendor who was sending us API calls didn't include the actual readable name of the facility or the devices that were in alarm. They were just ID numbers. So for each call coming in, we would have to make 2 calls back for the facility name and the device name. So each alarm resulted in 3 API calls, 1 to us, 2 back to them. We originally had a facility index that was built on a traditional relational database, but this is way back and it wasn't complete. So we were relying on the API calls. So by building up a facility index using Memgraph, we were able to cut the API calls by 2/3 without having to go back to the vendor. So now when the vendor sends us an alarm, we do a quick check in Memgraph to see if we have that facility. Say they come back with facility XYZ as an alarm. We do a check on our Memgraph database to see, do I even have facility XYZ currently? Is it one that got missed in the original scan, or is it a facility that we haven't seen yet? And we can add it in real time, which is really nice. So we just add it in real time, and then the next time we get an alarm from that building, we don't have to do those calls. So yeah, using the graph database as our facility index cut down the traffic in this particular case probably by 2/3.
And that's really nice to hear. I think it really emphasizes well the strength of having Memgraph in that system.
Mm-hmm.
So yeah, that's really nice. I don't see we have any more questions, but I think that questions were really nice. And Michael, all of the responses were really educational. The presentation was awesome. And thank you so much for presenting and being a part of Memgraph Community Call. I think that the community will truly appreciate it for sharing your story.
Awesome. Thank you very much. I appreciate everybody's time, and thank you very much for inviting me.
Thank you, and I hope to see you soon as well. Bye, everyone.